All right. So today we're not going to go too much farther than we just did yesterday. Okay. We're going to still look at solving using square roots, but then we're going to kind of use that to jump into talking about those complex or imaginary numbers. All right. So let me show you what I mean. Okay. So we'll say this is solving quadratic equations using square roots. And we'll say imaginary solutions. Okay, so again, we'll just kind of review that. Okay. So just to quickly refresh your memory a little bit here, before we get into an actual equation, right, just to refresh your memory a little bit, if we have something like the square root of -3, okay, this is imaginary. Okay. And again, part of the reason why I think we call it imaginary is that, you know, for this to be for this to be something, for this to happen, right, that square root of -3, well, that means we started with something from, like, right, we would have started with something like this, that x squared is equal to -3, we then square root both sides, and we end up with this kind of situation. Although technically, I guess I should put a plus or minus in front there, but I'll hold on to that for now. Okay? So if we go back to this step right here, imagine trying to think of some number that when you square it gives you a negative answer, right? If you think about a positive number, like let's just say, I don't know, like, you know, 2, right? If you think about 2 times 2, or a positive times a positive, what kind of sign will your answer be? You take a positive number and you multiply it with a positive number, what sign will the answer be? Positive, right? Positive times a positive is a positive, okay? So then what's the other option? Well, the other option is we could put in a negative number here. But if you have a negative number and you square it, that's going to be a negative times a negative, and what does that give you? Positive as well, right? And so we're kind of out of options. The only other option is 0, right, from the numbers that we know, 0 squared, but that's going to give us 0. Again, there's no way for us to take a number, multiply it by itself. If it's a positive, you'll do a positive times a positive, and you'll end up with a positive number, which we need a negative. And if you have a negative, then it'll be negative times a negative, which is going to be positive as well. And again, we need a negative number. So we have to introduce this new idea here, this old idea, but a different idea than just positive and negative numbers. This idea of imaginary numbers. Okay? And so what we talk about here, and again, when you simplify that, so when you have the square root of -3, okay, we introduce the idea of the square root of -1, right? So we break this square root of -3 up into its negative part and its positive part. Okay? So root -3 is the same thing as root -1 times root 3. Okay? The square root of -1, we just kind of define, okay, to be this letter I. And I use like a little curly tail on the end of the I so it, you know, kind of stands out or whatever. It looks a little bit different. Okay? So anytime we have the square root of -1, like right here, we'll rewrite that as I, and then we'll have the rest of the positive part right there. And so the square root of -3 ends up being just I times the square root of 3. And that's the best we can kind of do there. Okay. And we'll do some arithmetic with that today, like multiply stuff, all that jazz. Okay. But this is the crucial fact to remember right here. Okay, that the square root of -1 is I. Okay? All right, so let's just do a problem here real quick. So let's just do another example. Okay, so let's just solve using square roots. Okay, so let's say we have x squared plus 12 is equal to 0. Okay, so Shane, what would we do here to start solving this equation? So subtract 12 on both sides. You got it. X squared is equal to negative 12. And then what should we do, Shane, to both sides here? Square root, right? Okay. And so you get x equals. Now, again, we're in an equation, so I'll put a plus or minus in front there. And then I have the square root of negative 12. Okay. Since we're taking the square root of a negative number, we're going to rewrite this as plus or minus still, the square root of negative 1 times the square root of 12. Okay, so again, we kind of pull apart the negative part and the positive part there. Okay. What is the square root of negative 1? I. Exactly. So it's going to be plus or minus I times the square root of 12. Okay. Are we finished now? What do you guys think? Can we simplify the square root of 12 at all? Yes. What's a perfect square? What's a perfect square that divides 12? Okay, so 2 and 6 do divide 12, but 2, not 2 or 6 are square roots, but 4, right? 4 would work, yeah. So root 12 is the same thing as plus or minus I square root of 4 times the square root of 3. Okay, so again, I took that 12 and we broke it up into a product of two things, root 4 and root 3. So square root of 4 is 2. So I have 2I times the square root of 3. And that is our final answer there. Okay. So you can see that the solving is the easy part almost, right? Or it's the quicker part here. Or about, well, it's about half the work, maybe we'll say. It's about half the work. And then the rest of the work is us trying to simplify stuff. That takes time too. Okay. Questions on any of that? We'll do one more here, and then I'll have you guys try one. Or two. Okay. Let's do one more here together. 4x squared plus 11 equals 6. Okay, I'll zoom out a little bit so you can kind of see some of that earlier work that we did there too. Okay, so same directions. We'll solve using square roots, right? Okay. All right, so let's see here. Let's go to Chris. So Chris, what should we do here to start solving this equation?
Subtract 11.
Subtract 11 from both sides. You got it. So that's negative 5. Okay, and then Chris?
Divided by 4.
Divide both sides by 4. You got it. Okay, and then?
Square root.
Square root. You got it. Okay, so you get x equals plus or minus the square root of 5 over 4 like that. Oops, negative 5 over 4. I missed the negative. Okay. All right. So we're taking the square root of a negative. So I'll pull the negative out, and we'll make it square root of negative 1 times the square root of 5 over 4. Okay. See that again. It was a square root of negative 5/4. Now it's a square root of negative 1 times the square root of 5/4, right? So I can pull that negative out. And again, what is the square root of negative 1? This is just I, right? Okay? So plus or minus I root 5 over 4. But we can simplify just a little bit more here, right? Because that fraction will make this plus or minus I root 5 over root 4 like that. Okay. So again, when you take the square root of a fraction, it's the same as taking the square root of the numerator over the square root of the denominator. Right? So I broke up the square root there. Okay, and I did that because what's the square root of 4? 2, right? So I get plus or minus I times root 5 over 2. Can we simplify the square root of 5? Oops, I'm off the screen. There you go. Can I simplify the square root of 5 at all? No, right? There's no perfect squares that divide 5. So this is our final answer. Okay? So you got your work cut out for you, right? Getting to this point where we get the x by itself, that's half of the work. The other half is then simplifying this to a point where we can kind of stop and say, okay, there's our final answer. So how do we know we've simplified it enough? You want to check to make sure. Can I divide out any more perfect squares, right? Root 5, there's no more perfect squares. I can divide out of it except for 1, which doesn't really reduce it. Right? So check to see, can I pull out any more perfect squares?
No.
Do I have a square root in the denominator? So there's no, right? Do I have a square root in the denominator? Not anymore. And then also, is it a square root of a negative? Make sure it's imaginary. Okay, so let's give you guys 2 to try here. Okay. So I'll zoom out a little bit so you can kind of see one example at least. So here's 2 to try. Okay, so 1/4 x squared plus 9 is equal to 0. And then negative 5 x squared plus 3 equals 10. And again, solve using square roots. Okay, so try both of these here. See what you can come up with. And I'll walk around here and help you if you need it. Rohan's available too, if you need him as well. If I'm busy or whatever. So, yes. Do you want to try one of these first real quick and then just to make sure you're okay? If you really got to go, then go ahead. Just keep going, just make sure you're okay. Oops, that's kind of crooked. Lots of little details to keep track of here. I'll give you this much. Both of them should end up being imaginary. Both should end up being imaginary. Both should end up being imaginary. So you should have an I in both of your answers. Okay, one more minute here, one more minute. One more minute. All right, let's go to Luke P. How about the first one there, Luke? What'd you do here?
So the first thing I did was subtract 9.
Subtract 9 on both sides. Sounds like a good plan. Okay, so that cancels out. We have 1 over 4x squared equals negative 9. Okay, and then?
Next thing I did was divide by 1/4.
Divide by 1/4. Yep, so that's one option. Remember, folks, anytime you have like a fraction, you want to get rid of it, instead of dividing by that fraction, you could also multiply by its reciprocal. That might be some easier math if you want to try and do it mentally, right? Because in my opinion, like trying to think about negative 9 divided by 1/4, that's like hard to think about without a calculator, of course. But if you have a calculator, feel free to use that too. That's fine. Okay, so negative 9 divided by 1/4 is negative 36, right? Okay. And then what, Luke?
Square root it.
Square root both sides. Okay, and so what did you simplify that square root of negative 36 to be?
So I wrote out that x equals plus or minus root negative 1 times the root 36.
Okay, great. So let's just pause and just take that in here real quick, right? Luke saw here we're taking the square root of a negative number, right? So he went ahead and broke it up, but he also remembered to put that plus or minus in front, which is very important as well, okay? A lot of little details there. Very good. What is the square root of negative 1? What did you write for that?
Just wrote I.
And then what's the square root of 36 there, Luke?
Square root of 36 is 6.
Yeah, so we end up with then plus or, if you write I times 6, that's fine, but more typically we write the I after the number like that. And so the answer is plus or minus 6I. Okay? Because that's what you should have gotten. Questions on number 1? No questions? Yeah.
Could we get points to come off if we didn't put the plus or minus?
Potentially, yeah. Yeah. The reason for that is because the directions are asking you to solve, right? So, and the solve using the square roots, but the solve part is really what the key is here. Okay? That solve means you want to find all the possible solutions. If you don't put plus or minus, then that means you're just putting positive, which means you're missing one of the solutions. There's a positive solution, right? Positive 6i as a solution, but also negative 6i as a solution too. Okay? And again, if you want to check it, you can always, use your graphing calculator. There is an I button on your graphing calculator. If you did not know this, okay, so you press the second button and then the decimal point, second decimal, there's I, right? So if I take, for example, my original equation here, 1/4, and then I put in 6i as one of my answers and square it, okay, and I add 9, we get our 0, right? And then if I do the same thing, but now I make it a negative 6i, because our answers are positive 6i and negative 6i, we also get 0, right? And so that makes the equation true. Both a 6i and a negative 6i make our equation 0, which is what we're supposed to equal. So you want to put all your solutions in. So will I take like a ton of points off, Tyler? Probably not. But I mean, you want to give all the possible solutions here. All right, number 2. Let's go to Christian. Christian, number 2. What do we do here? Subtract 3. Negative 5x squared equals 7. Okay, and then divide by negative 5. Get x squared equals, so yeah, that's going to be negative 7 over 5. And then square root. You got it. Very good. Okay. So we have x equals plus or minus, and again, we're going to have the square root of a negative number. So I'll go ahead and break this up here. We got a negative 1, and we have the square root of 7/5. Okay. And the square root of negative 1, what's that? What are we going to write in place of that square root of negative 1 there, Christian? I. And the square root of 7/5, okay, we can't quite leave it like this because that leaves us a square root in the denominator, right? We're not allowed to leave a square root in the denominator. So, what do I want to multiply by here, Christian? Were you able to simplify this, or do you know?
No, I just kind of left it like that.
So do you know what I should multiply by here to get rid of the square root of 5 in the denominator?
No.
It's just root 5 again, like that. And then root 5 in the numerator, too. That's all there is to it, okay? And so we get plus or minus I. Root 5 times root 5 is going to be root 25, right? 5 times 5, 25. And then root 7 times root 5, root 35. Okay? But the whole point of that is, what is the square root of 25, Christian? 5. So you get plus or minus I root 35 over 5. Okay? Those are our final answers. Because can I divide any perfect squares out of 35? No, right? What about this 5 and the 35? Can I simplify those? Can I cancel that out, right? 35 divides by 5. Can I simplify those? Can I divide these? No. Why not? What kind of clues is in here that these can't be divided? Tyler?
You know, 35 is the square root form.
Yeah, exactly. 35 is underneath the square root. The 5 is not. Okay? So we can't quite combine these. If the 5 was in a square root, then yes, you could simplify it like that. Okay? Or if the 35 was outside of the square root, right, then you could simplify it. But one's in a square root, one is not, so you can't put them together like that. You just leave it. Root 35 over 5. And that's our final answer. Questions on any of that? Yeah, go ahead. And Paige, if you wanted to go still, you can go. Thank you for waiting, though. All right, I got a little bit more here I want to show you about these these imaginary numbers. Okay, so because we're going to use a little bit of arithmetic with complex numbers too. Okay, I want to talk a little bit more about these complex numbers, or imaginary numbers, I should say. So, complex numbers. Any number that can be written in the form A plus B times I.
Can I go to the bathroom?
Can you wait until Jake comes back? And then yes. Okay. So the A part of a complex number is known as the real part. And then the BI part of a complex number is known as the imaginary part. Put those in quotes. Okay. So complex numbers are a combination of real and imaginary numbers together. So what do we end up with? Here's what we kind of end up with. You guys have ever seen like a Venn diagram before, right? So I'll kind of make a little Venn diagram here. Make a big old box. Okay, so the complex number is the big box here. That's numbers like 3 plus 4i, or 4 minus 2i, or 1 minus I times the square root of 5. Within the complex numbers is the real numbers. So the real numbers, all those real numbers that we ever talk about, they all fit inside the complex numbers. And what are examples of real numbers? Well, like 17, 3/4, the square root of 2, pi. Those are all real numbers. Okay, notice they fit inside the complex numbers because complex numbers have the real numbers and imaginary numbers combined together. So any of these real numbers right here, 17, 3/4, root 2, pi, those could all be just A. And then also contained in the complex numbers are the imaginary numbers. Okay, and that includes like 2i. I square root of 11. Negative 7i. Okay. So the complex numbers are now the biggest set of numbers that we know. Okay. The complex numbers are now the biggest set of numbers that we know, right? It contains both the real numbers and the imaginary numbers and combined. Okay, along with then these combinations of real and imaginary numbers. So let's just identify. Let's take a look at this, right? What's the real part? What's the real part of this complex number here? 9. Yeah, not your question. That's the real part. Okay. What's the imaginary part of this complex number?
5i.
Yeah, the 5i. Yeah, again. How did we know that that's the imaginary part? What's with it? What makes it? The I. The I makes this imaginary. This one does not have an I, so that's the real part. It's that simple. Okay? And this is then, because it's a real combined with an imaginary, this is then a complex number. The whole thing together, complex number. Okay? Compare this to like negative 7i. What's the real part of this number? What's the real part of this number right here?
The negative.
So yeah, there isn't anything, is there, right? The negative is not a number, it's just a sign, right? There's no real part in front here. Let me ask you an easier question. What's the imaginary part of this number? The I and the negative 7. Okay, so this together, that's the imaginary part. The real part, there isn't any. So what number could we say then is the real part over here? There's no number, so what number do we use to represent no number?
0.
0, right, yeah. So we could say it's 0 there. Okay, so the real part is 0. So this is just an imaginary number, but it's also complex. Okay? So this one was only complex because it has both real and imaginary. This one is imaginary because it's got the I, but then it's also complex. Okay? Because it's part of the, if it's imaginary, it's also complex. Okay? Just trying to help you identify the different numbers and stuff like that. Okay? We can add and subtract compound or complex numbers. Okay, so I'll show you how to add and subtract complex numbers. Let's do an addition. And then we'll do a subtraction. Okay. I bet you guys already have a pretty good idea about how you're supposed to add these together. Okay. What should be combined together here in this problem? If I want to add this complex number and this complex number, what can we put together, you think? What do you think goes together here? Okay, so the i's, right? So 2i minus 11i is going to give us negative 9i. What else goes together? So again, we combine, Paige said, let's combine the i's together. That's right. And we did. We got negative 9i. Okay? What?
Are they called constants or something?
Yeah, the constants are just like the real numbers too. Mm-hmm. These constants, right? The negative 7 and the 5 can also go together. What's negative 7 plus 5? Negative 2. And so there's the real part right there. So these also go together. And there's our final answer. That's it. So what is adding and subtracting complex numbers? It's combining like terms. That's all it is when you add or subtract. Combining like terms. All right, let's try subtracting here too, just to make sure we're okay with that. Minus 2 plus 3i. Okay, so here we have a number, complex number minus a complex number. Okay. When we have a subtraction in front of parentheses, what do we have to do with that minus sign? Distribute it. So change it to a positive in the front, and then we'll just make this opposite like that. Okay, so we're going to distribute the minus sign by making the minus sign positive. And maybe I should have done that with like a red. Make it stand out a little bit more there. Okay. And so now again, same thing. We're going to just combine like terms. So 18 to the negative 2 makes 16. Okay, so that's easy. And then 27 take away 3, 24. And there's our answer. Okay. When Nick comes back, yes. All right, if you don't mind waiting, please. Unless it's an emergency, then you can go. All right. One thing I want to point out here real quick, and then I want to show you multiplication. Okay, so we're going to do multiplication. If you have a graphing calculator, this is again an example of where the graphing calculator makes it super easy for you. Let's say, for example, here I want to take 18 plus 27i and subtract my original problem of the 2 plus 3i. So 18 plus 27i, okay, minus 2 plus 3i. That was the original problem, right?
How did you type the
I is second button, and then the decimal point. Second decimal indicates the I. And look at that. 16 plus 24i, 16 plus 24i. Okay, the calculator will do it for you. So if you don't have a graphing calculator, you're missing out on making it life really easy for yourself there. Okay. All right, let me show you multiplication here, and then I'll get you guys started on your homework. We're not going to do division. Okay, so don't worry about that one. Okay. Multiplication. If you feel like you have to go that bad, you can go. Of course.
It's not like that.
I know it's not like that, but just in case it is, you got to go. You go. Mm-hmm. All right. I respect you respecting that. Waiting to. All right. So anyway, we're multiplying here, complex numbers. Okay. You can look at this and you see here it looks like a binomial, right? We have two terms here, and we're multiplying with these two terms. So in other words, we can use FOIL here if you want to, right? So you can FOIL it out. So like you can do 6 times the 3, 6 times the minus 10i. So 6 times 3 will give us 18. 6 times minus 10 is minus 60i. Right? So far so good. 6 times 3. 6 times minus 10i. Okay. What else do we need to multiply? Well, the negative 5i has to multiply with what? The 3. And the negative 5i also has to multiply with the negative 10i. Okay. Negative 5i times 3, negative 15i. Negative 5i times negative 10. What's that going to give us? If I multiply these two things together, what's going to be the result? Positive 50, right? Because negative 5 times negative 10 is positive 50. What about I times I? What's I times I equal to? I squared. Yeah, exactly right. I squared. Okay? Now, we haven't talked about I squared yet. Let's go ahead and combine our like terms here. So negative 60 minus 15 is negative 75i. And then 50, and I'm going to hold off, I squared. Remember, what does I equal again? What does just plain old I equal? The square root of negative 1, right? So, which is, as we said, do I have it on this paper? No, I don't. Okay. So remember, I is equal to the square root of negative 1. So then that would mean I squared, what would that equal? Negative 1. Okay? If we have I, and it's equal to the square root of negative 1, and if I square both sides, I squared, then I get negative 1. Right? If you square a square root, it cancels it out. You're left with negative 1. So in other words, 50i squared is the same thing as 50 times negative 1. Which really means this is 18 minus 75i minus 50. And so we can combine the 18 and the minus 50. And that's negative 32 minus 75i. And that is our final answer there. Okay. And again, if you have a graphing calculator, well, that was convenient. Fluttered right down to me. If you have a graphing calculator, okay, you can type into that graphing calculator what you see right here, parentheses 6 minus 5i, parentheses 3 minus 10i, Okay, see what I typed in right there. It's the same thing as what we had. Hit enter. Your calculator does all the work for you, and it gives you exactly that final answer there. Okay. So, now, none of this is like crazy difficult, right? It's just, this is work, that's all. You're just like working it out, stuff like that. Okay? But the key thing to remember here, when you're multiplying those complex numbers, when you see an I squared, change that to a negative 1, right? I squared, 50I squared became 50 times negative 1. And then you just simplify like you normally would. All right. Questions on any of that? Excuse me. Very good. Then, let me get you guys started on your assignment. Okay. Assignment will be out of the book. And you have oodles of time to work on it. Yeah, if you need to go, yeah, good. Okay, so it will be in section 3-2. Let me get you the page numbers here. That's 3-1. 3-2 starts on, or the homework starts on page 96. So 3-2, page 96. Okay, numbers. Three. Ooh. 3 through 17 odd. Okay. Yep, 3 to 17, the odds. So if you need a spare book, there's a few spare books in the back there. Just please make sure they go back on the bookshelf before you leave, okay? Sure, yeah. try and help you access it online, or are you going to be fine with just this? Okay. Find it okay.
Mr. Wood, did you record the present? Did you record today?
I did. Oh, in fact, I need to stop the recording and
Oh, hey.
start compiling the video.
They know I'm there now.
That's right. You're internet famous. All 5 of my followers will